Hello friends, let's continue our journey to learn Agentic AI. We did couple of videos on the basics, fundamentals of learning Agentic AI. Then we did a couple of them on how to utilize and implement the use cases on Agentic AI. Now let's do some on evaluating and testing the Agentic AI solutions, be it Agentic AI framework solution or voice agent solution, right? So we will divide this into 2 to 3 videos. One video will be sharing the practical knowledge and implementation of it. So first let's understand the theory on doing the bias evaluation and testing the Agentic AI solution. Similar concept is applicable to even large language models or any language models which are implemented, right? So the Agentic AI solution need to be bias free for ethical AI and needs to be accurate and can be measured on perplexity, fuzziness, and other parameters. The agentic part to fair AI. So it is done in 3 stages: pre-process stage, in-process stage, and post-process stage. So pre-process stage is when we get the data and we create the models, and we want to make sure the data is suitable for the requirement. Like there are tools available where we can give the data input, and based on what kind of solution we are doing, whether it's a text generation, question answer, summarization, or text classification, accordingly it can be evaluated based on toxicity and other parameters, right? Robustness and so on. So any agent will have a voice agent will have speech to text, so it should be able to recognize different voices, different demography, gender, and so on. Then within workflow framework solutions, we have planners, we have safety agents. So those agents should not add bias to the output which they are generating. So the like it's that is the part of in-process validation of bias. So what are the different stages? Like in pre-process, we have data. So the data needs to be curated and need to be bias free. So if you take any domain data like healthcare or like that, historically it may be biased for nurse as a female, or doctors as only male, engineers as only male. So such bias needs to be removed. Okay. Then we need to in process needs to have multi-agent safeguard. So like if there is some healthcare solution input, first planner gives the output, whereas medicine of certain milligram needs to be taken. By the time it reaches the end, it changes it. So such bias may get added, or based on different voice it may give different outputs. So such testing need to be done, and the solution has to be uniform for every person interacting with the solution. Okay. So the final stage is deployment and evaluation. So once it goes into production, how we to evaluate it. So in our next video we will do a practical session where how we can test the retrieval augmented generation knowledge base, how to do the visualization using box plot, or you can choose any other visualization which is understandable and serves the purpose, right? So for a voice agent, one can do the persona based stress testing in a male, female, young, old, different ethnicity, different region. So based on the solution to which area it is catering, we can find out the demography of it and accordingly have the agents to test it. Like then there we can have a multi-dimensional evaluation where we check the word error rate, toxicity, perplexity, fuzziness, accuracy, distortion, and so on. Now there is an additional parameter which we need to look into, like whenever we use any language model, so we have different variables to set, like temperature, p value, k value, and so on. So based on that, the output is discriminative or generative, so that also affects the output, and those parameters needs to be considered while doing the evaluation. So in short, we should create a orthogonal array of mix of such parameter setting and different language model settings, and accordingly doing the using different algorithms, whether we are using cosine similarity, keyword similarity, and so on. And if required, based on the outcome and the score, we can do the human escalation for audit. It can be done in a lazy loop to improve the entire solution, or if the score is very low, immediately human can intervene. Like for sending an email, instead of directly sending an email, it could put it into the draft of the administrator who can review it. So different bias categories which we need to address. It depends on solution to solution, but by and large, human and data bias. So data bias could be because of historical data which we are using, or the data which is available. Like one of the example given in one of the AI summit was like, if you ask AI to create a person drawing a painting, it always create a one with doing a right hand and not with the left hand, right? Algorithmic bias. So there are algorithms used which include, or the agents, the way we write, or the vector embeddings, which generate models which generate which retrieve the information and draft it. So such bias needs to be taken care of. Domain specific bias, so like there are words related to certain industry, healthcare, life science, so all those words needs to be added, and accordingly it should be able to understand it and make it bias free. So for a fairness check, it has to be done at different stage, pre-processing data. So data before we take in, data size also we need to consider, velocity, veracity, and volume. Accordingly, solution should be able to handle it. Then the model selection, we may select different language models. We may always need top 2 to 3 models be available to us, so that if one model is not working, alternative other model should be available to standby. Agent communication. So how one agent to another agent the information goes is that there is a data lineage, data governance is consistent, or is there any change in the output. So decision aggregation. So if we from one agent to another agent the output goes and the decision keeps on aggregating, is there is a big delta or a change, so a score can be done by a fairness agent before giving it to the guardrail. Okay. So similarly, post-processing audit can be done in a lazy loop, which we will see in the video when we do the discuss the practical implementation. So bias is no longer just a model problem; it's a system property. So we no more use just perplexity or a language chat GPT kind of solutions, which are like user asking question to the model and it is giving you the output based on it's a question answer or a summarization or a description or a code generation. Right, in an agentic workflow, the input goes to the planner, then to planner based on the need of and the requirement of the question, from the intent it finds the goal, and it may get call retrieval agent to get the information from the knowledge base. It may use tool API, SERP API calls or to get the additional information, and it may do the evaluation using synthesizer, combining the answers or doing the score of the answer, which can be given to the fairness check to do the bias evaluation before giving it to the guardrail. So the loop goes into 3 stages: pre-process, in-process, and post-process. So pre-processing stage is the start of the project, when we collect the information, data, and the tools which we need to use, and the prompts we define. Okay. So we can do A/B testing, where we have multiple agents handling versions of the prompt for the same agent, handling the input, and then we score it which agent is best doing the job. Accordingly, we can do the reinforcement learning or reason and act agents to evaluate and correct the output. While in processing stage, when the user has asked the question and the agentic workflow or a voice agent is processing the request and formalizing the response, we need to check that at the stage of every agent how the output is changing, and if it is a voice agent, how the speech to text, text to speech conversion is happening. In post processing, our outputs are evaluated, monitored, and adjusted, right? So we'll see with the help of agent how we can do this evaluation, and for a long-term solution we can use artificial intelligence libraries available in Python or Studio to write a detailed solution, and it can be compared with the agentic solution for the confirmation of whether the agent is working as giving the score, doing the scoring as expected. So in pre-processing stage, what we need to do, we get the data, and raw data needs to be cleaned and processed. So like in any even artificial intelligence data processing, we do the data cleaning, normalization, removing the outliers, checking for the standard deviations. Similarly, in case of generative AI, based on what kind of mode we are doing, we need to refine the data and make it suitable to use. So there are 3 steps. We do the data preparation, that is data cleaning. Then we do the grounding and taxonomy based on what domain it is, add the words and specific to that industry and domain. And then we do the feature design to take care of the demography and reduce the noise, right? So like you have some data which is having certain patterns based on gender, history, demography, and so on. So the data needs to be made neutral. So we can do it with the help of AI tools or with writing the agents and remove the bias from the data. Then we do the data should be fairly representing if there are any outliers. So like generally in day-to-day life also surveys are done. If the sample population is not correct, the representation is not fair, right? And whatever data is there, it should be able to provide the right context for the goal to the planning agent, and it should be neutral. So let's take an example of a voice agent in a healthcare. Like, so if a user asks any question to the agent and so speech to text needs to understand it, so it needs to be tested with different accents. And accordingly, based on that results, we need to curate it, and then after curation, test it and measure for the word error rates. Is it able to understand the pronunciation from different users, and how accurately it is able to understand it? And so based on that, we can make sure in the pre-processing stage, the voice agent and library is working as expected. So next stage is in processing. So in processing, in a multi-agent system, we have the planners or the orchestrator which will take the input, then there will be the processing of the data information to get the output, and then the output is scored, and the manager manages it to route to different tasks, take the relevant access actions, synthesize it, and then pass it to the fairness agent. So we should have a fairness agent before the guardrail in the in processing stage of the solution. So the fairness agent job is to do the critics and vetoing the skewed outputs, right? So if there are any outliers or like how the responses have been historically given to the other users, is it deviating from it? Accordingly it will raise the flag. So how we can decide the create the system prompt for a fairness guardian, and we can define the constraints, whether to disallow discriminatory language or decision based on no decision based on protected attributes, right? Based on certain industry, certain parameters cannot be taken into consideration, so accordingly it should filter it. Yeah, in spite of fine-tuning the language model and all the care is taken, if there is a chance of some data getting percolated, so for that such constraints should be utilized. So this can be done in 3 different stages. System prompts, so we can every system prompt for every agent can handle the check of the fairness before giving the output to the next stage, or it can be done in the form of chain of thoughts. And the other way is the natural language unit or the natural language generation agents can be adversarially trained for handling fairness checks. While doing all these things, we need to consider latency of the and the response based on what kind of solution we are building it. How will the fairness agent work? So the fairness agent will take the in the flow of the workflow, once the planner and the tool execution is done by the agent collecting RAG information or API calls, the output will be sent to for the fairness check. If the fairness check is not correct, the information can be stored in a short-term memory or a long-term memory with some unique ID, and the input is looped back to the planner and tool. After execution, fairness check will check it again and see if the score has improved, and it will consider the historical data from short-term memory or a Cosmos DB or a Dynamo DB, and then pass on the output to the guardrail or finally to the user. So let's take the example of a in processing flow. so like suppose there is an agent which scores the different resumes, CVs received, and how a fairness agent can be used to correct it. So like a planner will design the hiring workflow. It can be dynamically done, as I mentioned in the earlier one of the videos, or a hard-coded solution will be there. So the retrieval agent will fetch the resumes. It will score then the scoring agent will score the candidates. So what fairness agent will do is it will check the scores, and if there is any demographic skew or the gender skew, it will push back those results to the scorer and the flow to re-evaluate it, right? So if the scorer agent produces a ranking with systematic demographic skew, the fairness agent pushes back, triggering a re-ranking process. So let's understand the last post-processing, the safety net. It will work like a safety net. So like if there is any information which is leaked at the pre-processing and in-processing stage, so it should be caught at the post-processing. So guardrails are the one way of doing it. So other way is you run the simulations at large scale in the background, and it keeps doing the stress testing and see how the system is responding. So then also there should be a mechanism agent to do the rejections based on the low confidence of the response. So how we can calculate all these things, we will understand in the practical session by creating an agent with the help of tools like N8N, which are no coding platforms, one can try such agents on its own and learn it. And for a practical professional solution, same can be implemented in Python and using different libraries like LangChain, LangGraph. I forgot to mention that Langsmith is a library which is taking care of doing all the evaluations, and but it is a paid solution. The demo I will do is with an unpaid solution, which you can yourself create it. Okay, so the next way of doing the safety net or the post processing evaluation is adjusting the outputs based on the scores and the re-ranking, setting the values of the temperature, p value, k value, and so on, right? So let's take an example. So whenever you want to test any solution, we need to create a orthogonal array based on different personas and their demography, and accordingly we can test it. So if it's a voice agent, you might have seen like LinkedIn talking to excuse me, like Siri talking to Alexa. So similarly, you can create a voice agent with boundaries as a test agent, and it can test the agent under production, right? So we can create such simulators, and I will share that in the future videos, how we can do it with the help of 11 labs, and then passing on the information by API over to tools like N8N, and then one can update test management tool, bug management tool. It can extract information like how many times the same information was repeatedly asked. Fine. Yeah, thank you. So so let's understand the example of how to handle a voice agent. Excuse me. So like suppose there is a call incoming and detector detects the call and it is not able to recognize the accent. It finds to be a new accent. So instead of a regular path of a standard solution, it can be diverted to the robust model variant, which can handle the variations of the different accents based on and demography and the age, and accordingly the system can be improvised and to handle different voices and noise. So the agentic fairness matrix we should evaluate based on word error rate. So whether it is able to correctly give the output from the vector embedding, and does it miss any information. So we can have a question and answer, expected answer, and the actual answer which we got, we can compare it to evaluate word error rate. Similarly, for bilingual evaluation under test, BLU is there, and then BERT is for evaluating the cosine similarity used for matching the information. So like any question we ask to the knowledge base, it is converted into a vector graph embedding, and based on that the other vectors are found in the knowledge base and answer is responded. Does it do correctly or not, it can be evaluated by doing the BERT score. Toxicity, if there is any harmful information or the language, though we define in the prompt of what language to be used, toxicity may be percolated. Fuzziness is if there is a clarity in the response or not. Perplexity is there any surprise, like even based on temperature and p-value settings, it may generate information instead of being more deterministic. Or is there any distortion of the information because of bias, historical, gender, or demographic bias? All such needs to be evaluated and make sure the accuracy of the output is correct. So how to evaluate in a workflow agent, multi-hop workflow. So it could be going from planner to execution agent to the synthesizer, with other agents in middle interacting with knowledge base or the API tool calls. Similarly, in voice agent, person may speak anything and it is converted to the text, and then the information is retrieved and finally the output is given. So while this flow is going on, whatever recommendation was done by the same agent, is there is a big deviation until it reaches the last stage, and if this deviation is high, accordingly corrective fairness check needs to intervene and correct or run the loop again. So for doing all the evaluation and by testing, we need to have adversarial and red team testing. So how it can be done is we look for the edge cases, and based on the edge cases we can do the human intervention. We test it with the adversarial prompts and see if the system breaks, and have a feedback loop mechanism in the form of lazy loops, or to do it after the communication is done, or while the communication is having, the feedback loop feeds back in and runs the process again and compares the score with the earlier score, and after correction sends the output to the guardrail and the user. So some of the things which for bias mitigation at every stage which we need to take care is, while doing pre-processing, we need to make sure taxonomy and grounding is done for every domain which we are creating the solution. For in processing stage, we should hard code the constraints in the fairness check and the guardrails. While in the post processing, if there is any low score, it should be rejected, and loop feedback has to activate. Similar, we give importance in the solution for the latency and accuracy. We do the scoring, and we use neighboring algorithms to check if the latency is there or not. Similarly, by doing the critical path length and so on. Similarly, accuracy we do, but at the same time the importance should be given to the fairness for ethical AI and best interest of the customer and the user of the solution. So there are different frameworks available in the market which one can utilize it. Let's do the quiz. I will read the questions. You can pause it to see the answers and then the hints. In three-stage bias framework, which action is primarily component of the pre-processing stage? Here are the options, and here is the hint. Next question: in a multi-agent system, what is the specific role of a fairness agent during in processing? Here are the options, and here is the hint. So all these questions have been also posted on the LinkedIn post where one can go and have a look. Why is measuring the WER per demographic group essential for voice-based AI agents? WER is the word error rate. Here are the options, and here is the hint. Next question: which technique involves training a model to hide protected attributes while maintaining task relevant patterns? Here are the options, and here is the hint. During processing, what is the benefit of using orthogonal arrays in persona-based simulations? Here are the options, and here are the hint. Which of the following describes algorithmic bias according to the source material? Here are the options, and here is the hint. How does an agentic workflow use reject options to ensure fairness in high-risk scenarios? Here is the options, and here is the hint. Next question: in the context of multi-agent evaluation, what is meant by LLM as a judge? Here are the options. And here is the hint. Next question, which metric is suggested for evaluating semantic similarity between an expected response and the agent's actual output? Here are the options. And here is the hint. Last question, what is adversarial training in the context of in-processing bias mitigation? Here are the options. And here is the hint. Now before we close, let's understand few important things which will be include later on. Let's kind of do a revise. So word rate error analysis, bilingual evaluation under study, mechanism, BERT score, that is for cosine similarity evaluation. Then while doing the large language model settings, we do the temperature, top V and top K values, how the penalty, it changes the way the output is deterministic or generative. Then for testing, we do the orthogonal arrays. So we, based on cosine similarity or the keyword search what we are using, we can do it along with the settings of the language model and what algorithm we are using, how many dimensions the vector embedding has. Based on such combinations, we can do the evaluation, right? And then one thing which I forgot to mention is like the system fairness system agent should be able to not just correct it, but also it should be able to suppress the information which is adding bias, right? Other than that, we said like how to do the evaluation of the data set for toxicity and other parameters based on what is the solution you are building, whether it's a text generation, question answer, summarization or classification, right? We will see based on natural language processing for a knowledge base how to create questions, sub questions, expected answers for every question, how it can be asked in a different way, and create those question variations and see how the solution is behaving, and then doing the box plot for the evaluation. And so different biases are human bias, gender bias, religion and culture bias, algorithmic and systematic bias, observer bias, prejudice bias, emotions, assent, it could be a historical bias. Then the other parameters are coherence, relevance, fairness, overall evaluation, and so on. Right, so these are the parameters based on which a solution should be built. In the next video, we will do understand the actual agent and how it can be used to test knowledge base, and it's a generic solution which can be used can be built for testing any product in the organization. Thank you.